So thinking back to chapter 2, when we introduced the idea of a frequency distribution, our goal was essentially to take some pile of numbers and turn it back into a table, a graph, some representation that more clearly represented patterns and information in a way that was easily digestible, or at least more easily than the pile. With probabilities, we are essentially doing the same thing, where here we're going to talk about discrete probability distributions. We're going to talk about distributions for discrete things in particular in chapter 4. Though understand a lot of the constructions we're seeing here will hold just as well for when we get into chapter 5 and start talking about more continuous things, specifically the normal distribution in particular. But just bear in mind here that essentially we're marrying those ideas from chapter 2 to our ideas from chapter 3 with probabilities. So we're making tables where our table will consist of probabilities associated to given events. So because we're talking about probabilities, we have the rules for probabilities must be observed in the distribution. That is, all of our probabilities have to be between 0 and 1 inclusive, which we can denote like so mathematically. 0 is less than or equal to p of x, the probability associated to event x, which is less than or equal to 1. And also, all values in our distribution have to add up to 1. The sum over all the events x of our probabilities is 1. To see this, we'll look at an example where we want to verify that the distribution for the 3-day forecast and number of days of rain is actually a probability distribution. So for this type of problem, what we have to do here essentially is see that the table we're given actually meets those two criteria. So in the first case, we just want to make sure that the smallest value is at least 0. In this case, our smallest value is about 6%, while the largest is going to be 0.432. That is about 43%. So we're good on the first case. And generally, if we ever see a value that occurs less than 5% of the time, that is, it has a probability of less than 0.05, we say it's unusual. That's the sort of language that we talked about a bit with the empirical rule, and it's the sort of language we're going to be seeing again later when we start really digging into stuff with that normal distribution. But here, we get what we want, where the easy way sometimes to check is just to see if something's negative, can't work, and if something's bigger than 1, also can't work. In this case, we're good on that step, so we're going to go to the second part, which is checking that the sum of our probabilities, that is the sum over all events of p of x, is equal to 1. Here, that would be 0.216 plus 0.432 plus 0.288 plus 0.064 up to my handwriting, which here ends up being 1. So we have a valid distribution. And next, we're going to see a couple examples for how this can go wrong. That is what we're looking for to check when either of these things doesn't happen.